Assalamualaikum and greetings to the panels. My name is Nabila Huda. We are going to present our FYP proposal by the title of Modeling Dengue Incidence in Selangor using Negative Binomial Generalized Additive Model. So as an introduction, dengue fever is defined as a mosquito-borne disease which is caused by the dengue virus and is transmitted primarily by mosquitoes of Aedes aegypti species. So one of the prime symptoms of a person having dengue fever is by having high fever that reaches 40 degrees Celsius. There are many other symptoms such as vomiting and having severe headache. So the emergence of dengue fever started in China, which is from a disease related to flying insects named as water poison.
Assalamualaikum and hi, I am Nurul Izzah binti Azizan and I'm going to present on dengue in Malaysia. Dengue infection has been a first-rate public health concern in Malaysia ever since the first mentioned case. On November 15, 1902, Malaysia mentioned the primary outbreak of dengue infection transmission from Singapore to northern state of Penang. Since 1960s, instances of dengue have unfolded the urban region of Penang and Kuala Lumpur. By the early 1970s, dengue hemorrhagic fever or DHF had unfolded throughout Malaysia. In Malaysia, the annual number of cases of dengue infection has steadily increased since 1980, after the first epidemic outbreak in 1974. Figure 1.1 shows the annual number of reported dengue cases and the trend of dengue incidence in Malaysia between 2000 and 2021. Figure 1.2 shows the weekly dengue in Malaysia, while Figure 1.3 shows the statistics of dengue cases as of 2020 and 2021. Based on Figure 1.3, it is stated that Selangor had the highest number of cases recorded in both 2020 and 2021.
Due to the linearity assumption in GLM context or Generalized Linear Model, an extension to GLM was adopted into the study, which is Negative Binomial Generalized Additive Model, GAM. This is because GLM approach assumes a fixed linear or other parametric form of the relationship between the dependent variables and the covariates. In most real-world scenarios, the relationship between the dataset variables is not always linear, so a straight line does not adequately fit the data. The study compares how good is negative binomial GAM to give an accurate prediction of dengue incidence compared to GLM approach. The GAM approach is more flexible as it allows the replacement of the linear structure with a set of unknown smooth functions to explain more complex relationship. Therefore, the goal of this study is to see how well the negative binomial GAM predicts dengue incidence rates in Selangor.
The figure shows the theoretical framework of this study, which includes the temperature, rainfall, and relative humidity as the independent variable. So these three variables have a relationship with the dependent variable, which is the occurrence of dengue.
Next, I am going to present on the research question and the objective of the study. The research questions are: first, which districts of Selangor are dominant with dengue incidence? Second, is negative binomial GAM be a good alternative model to predict dengue incidence rate as compared to negative binomial GLM? The third one is, what are the climatic factors that are associated to the emergence of the dengue incidence? The objective of this study are: first, to identify dengue hotspots among 9 districts of Selangor using spatial mapping. The second one is to compare the model performance between negative binomial GLM and negative binomial GAM. And the last one is to determine the climatic factors that are associated to the emergence of dengue incidence.
Findings from this study can serve as a guidance to the public health decision makers in Malaysia regarding the contributing factors to dengue incidence in Selangor by district. Besides, the findings can verify the reliability of generalized additive model to be used to predict dengue incidence rate compared to using conventional generalized linear model.
The study only includes the dengue incidence occurred in 9 districts of Selangor. This is because Selangor has the highest dengue incidence rate, DIR, of all Malaysian states. A monthly basis of data set will be used where comprises from January 2017 to December 2021, which to be collected for every district in Selangor. Furthermore, the variables in study will only involve monthly dengue count, monthly average temperature, monthly amount of rainfall, monthly average of relative humidity and population. The statistical count model will consider the negative binomial GM and compare it with negative binomial GLM.
Chapter 2, Literature Review. This chapter begins with a review on factors affecting dengue transmission. The review on statistical application on dengue are also truly explained. Climatic factors influencing dengue incidence. Temperature. An ideal temperature for a mosquito to breed is between 25 to 30 degrees Celsius. In Palembang, viruses develop correctly with 24 to 39 degrees Celsius. Study shows the incidence of dengue in Port Sudan is likely to happen at the maximum temperature less than 35 degrees Celsius. Study in Nepal show a negative relationship for maximum temperature and dengue incidence at temperature higher than 35 degrees Celsius, while a positive relationship was found at 24 to 31 degrees Celsius. Rainfall. There is a positive relationship between rainfall and dengue transmission in the state of Selangor, Kuala Lumpur and Putrajaya, Cheong et al. 2013. A significant positive correlation with an increasing lag between weekly dengue cases and rainfall in Selangor and Petaling, Singh et al. 2022. Rainfall is one of the major indicators for dengue transmission according to Gama and Nakagoshi 2013. Relative humidity. Research in Sri Lanka reveals the humidity and temperature were found to have a continuous positive relationship with Aedes outbreak frequency. Messina et al. 2019 included that minimum annual relative humidity in model research as a positive contributor for dengue viruses transmission. In the rainy season and the simulated condition in Singapore show that the mosquito survival rate were at 93% and 90%.
In addition to climatic factors, there are also non-climatic factors that were listed by researchers as the factors influencing dengue incidence. So the first non-climatic factor is urbanization, which refers to the growth of urban areas and the rise in the population living there. So based from a journal by Key et al., it is said that people who live near the prefectural border or in urban areas have high risk of contracting dengue fever in the Pearl River Delta in China. In addition, unplanned urbanization could also lead to other problems such as inadequate infrastructure, poor housing conditions, and poor hygiene. So the next factor is human population density, which is the measurement of population that are specified in a certain area. So a study by Schmidt et al. Suggests that risk is the highest at very low population density. Additionally, in Thailand and Vietnam, dengue fever were more common in rural than urban areas due to lack of water supply, and since the density population in the rural area are higher. However, there is also a study in Indonesia that proved by using a correlation test that there is no significant correlation between population density and dengue fever. Okay, so last but not least, elevation refers to the height above a specified level, usually measured as above sea level. So the studies conducted in both Indonesia and Subang Jaya, Malaysia, shows that the higher a region means lower the incidence rate of dengue. Okay, so overall, the previous studies shown that there is a significant correlation between the elevation and dengue incidence.
There are various studies about dengue incidence which use different statistical approach. These studies were performed to identify whether climatic factors associated with infectious diseases. A study in Petaling Jaya proposed a GLM by using the Poisson and negative binomial distribution to examine the effects of the climatic factors on dengue incidence by considering the collinearity between variables. A GLM is made up of a linear predictor that can be written as shown here. And a linear predictor is specified by a link function denoted as G. The study revealed that climatic factors were statistically significant with dengue incidence, and most of them shown a negative effect. Another study in Pakistan that was conducted on 2021 used generalized linear mixed model GLMM and Markov-Chain-Monte-Carlo NCMC to determine the relationships and random effects of different social and climate factors on dengue transmission. A Markov chain is a sequence of random variables x1, x2, x3 until xn, where the equation can be written as shown above, where PR is a conditionally probability. In a meantime, the regression model is given by y equal to alpha plus beta x. The study indicates that GLMM shows the significant random effects of climate factors on dengue transmission during the study years.
Chapter 3. Research Methodology. Sources of data. First, dengue. The total number of dengue patients who were diagnosed based on dengue blood tests. This study will use monthly dengue incident vector-borne and infectious disease sector. The data will be collected from January 2017 to December 2021. Second, climatic factor. Temperature. The measure of hotness or coolness expressed using Fahrenheit and Celsius. Relative humidity. The amount of water vapor in the air that varies with temperature, which measured in percentage. Rainfall. The quantity of water that is precipitated in liquid form in a specified area and time interval measured in millimeters. The climatic data will be obtained at monthly basis from climatic data online. The study included the 9 districts of Selangor, and the geographical location of each district are tabulated as followed. The third one is population. Population of Selangor from 2017 to 2021 will be collected from Department of Statistics Malaysia, and the summary of data sources and the summary of variable are shown as below.
Data analysis begins with data exploration in order to evaluate the data behavior. The yearly and monthly temporal series for the climatic factors will be plotted. And besides, the trend of the yearly and monthly trend for dengue incidence rate by district in Selangor will be observed. A spatial map of the incidence rate will also be included.
A GAM is a GLM that includes a linear predictor made up of the sum of smooth covariate functions. The structure of the model is shown here. GAM have been effectively applied in a variety of research areas. It has been widely used as a prediction model in statistical applications because it is very flexible in describing the dependence of the response of the covariates. GAM is the common approach since it enables non-parametric adjustments for non-linear confounding effects of seasonality trends and weather variables. In addition to handling categorical predictors, GAM strength is its capacity to handle extremely nonlinear and non-monotonic relationships between the response and the predictor variables. GAM is therefore helpful when there is no priori justification for using a specific model, or when the relationship between the variables are expected to take on a more complex form and is difficult to fit by standard linear or non-linear models. The Poisson GAM can handle both over dispersion and under dispersion. Poisson distributions appears to be appropriate when the response variables consist of non-negative integers and is not normally distributed. Poisson regression is a modeling method for variables that describe discrete or count data of the occurrences of some event over a given interval. The negative binomial regression model was taken into consideration in the study as a generalization of the Poisson model to combat over-dispersion. It treats the distribution's parameter as a random variable in and of itself. The variance function in negative binomial is introduced when there is over-dispersion. Negative binomial distribution has been shown to be a powerful model because it captures the over-dispersion of the nature of the counted data. Over-dispersion is the existence of more variability in a dataset than what a specific statistical model would predict. Over-dispersion is a common problem in GM with fixed dispersion, such as Poisson and negative binomial GM. It occurs due to such factors as the presence, greater variance of response variable. To determine whether there is a presence of over-dispersion in the model, hypothesis testing can be conducted to test the likelihood of the model having over-dispersion. As we can see here, if null hypothesis indicates that there is no over-dispersion problem, then alternative hypothesis indicates there is over-dispersion problem. Test statistic would be LLP minus LLMB and multiply with -2, where LLP and LLMB is log likelihood of Poisson and negative binomial model respectively. For critical value, chi-square with 1 degree of freedom, and we made a decision: reject null hypothesis if test statistic is greater than critical value.
Negative binomial generalized linear model can be used to model count data, but it does not imply that the mean and variance are equal. Negative binomial GLM is also referred as a generalization of the GLM since the mean structure has additional parameter to model over-dispersion. Since there are possibilities of non-linear relations with explanatory variables in modeling dengue incidence rate, therefore we think that negative binomial GAM is more approachable than negative binomial GLM.
Lastly, goodness of fit for GAM model. There is 3 indicators used for model selection. The first one is archaic information criterion, a method for evaluating how good model fits the data, calculated from the number of independent variables and the maximum likelihood estimate for the model. The equation of AIC is as follows. The second one is Bayesian information criterion for model selection between a limited set of models, closely related to AIC and has been widely used for model identification in time series and linear regression. BIC is computed as follows. The last one is pseudo R-square, used to evaluating goodness of fit in regression model with categorical dependent variable. It do not represent the proportion of explained variance, but rather than improvement in model likelihood over a null model. Pseudo R-square equation are as follows. That is all from us. Thank you so much and have a great day.